Hello everyone. In this video, we are going to try to find the necessary condition for two quadratic equations to have a common root. So suppose we have two quadratic equations here, a sub 1 x squared plus b sub 1 x plus c sub 1 equals 0. And another one is a sub 2 x squared plus b sub 2 x plus c sub 2 equals 0. So we have been given these two quadratic equations and we have been told that they have a common root, and let's suppose that common root is alpha. So if each of those equations have a root alpha, then from the first equation we can say, so if he has a common root alpha, then obviously alpha should satisfy the equation. That means we can say, okay, a sub 1 alpha square. So in place of x squared, I'm now going to put the value of alpha for x. So I'm writing as a sub 1 alpha squared plus b sub 1 alpha plus c sub 1 must be equal to 0. That means if alpha is a root of that equation, then alpha must satisfy the equation. So this is our one very important equation here. So let's mark it as equation number 1. And then similarly, from the second equation also we can say, hey, because the second equation also has a root which is same as alpha, because alpha is also a root of the second equation, we can say, well, alpha must satisfy the second equation. That means in place of x, we can use alpha. So it would be a sub 2 alpha square plus b sub 2 times alpha plus c sub 2 is equal to 0. And let's say this is our equation number 2. Now, if we assume, let's make a couple of crazy assumptions here. Say suppose we say alpha squared is equal to u and alpha is equal to v. Let's assume that alpha squared is equal to u, another variable that I'm using, and alpha is equal to v. So with that assumption, we can use u in place of alpha squared and we can use v in place of alpha. So from the first equation we are going to get, so from equation number 1, we are going to get a sub 1 times u plus b sub 1 times v plus c sub 1 is equal to 0. And let's say this is our equation number 3. And similarly, from equation number 2, we can say that a sub 2 times u plus b sub 2 times v plus c sub 2 is equal to 0. And let's say this is our equation number 4. Now, if you look at equation number 3 and 4, they clearly look like a system of linear equations, like a pair of simultaneous linear equations, right? We know how to solve simultaneous equations by cross multiplication method. I have already done a separate video on that. Feel free to watch it. Now, we are going to use the same technique here to solve these two simultaneous equations to find the value of u and v using the cross multiplication method. So let's do that. Now we know using the cross multiplication method, we get the value of u and v like this. So it will be u divided by bc minus bc. We are going to write 1, 2, then sub 2, 1. And that will be equal to v divided by c a minus c a. Again, we are going to use the subscript 1, 2, 2, 1, and that will be equal to 1 divided by a b minus a b, and the subscript would be 1, 2, and then 2, 1. So this comes straight from the cross multiplication method of solving the system of linear equations, right? So now here, let's replace the value of u and v. We know u is nothing but alpha squared and v is alpha. So from here, I'm going to say, okay, from here we can say that alpha squared, in place of u, I'm just writing alpha squared. So alpha squared divided by b sub 1 c sub 2 minus b sub 2 c sub 1 is equal to, then again I'm going to write alpha in place of v. So I'm going to write alpha here. So alpha divided by c sub 1 a sub 2 minus c sub 2 a sub 1 is equal to 1 divided by a sub 1 b sub 2 minus a sub 2 b sub 1. I hope it is clear up to this point. So from here we can say, okay, what is the value of alpha? Well, from here let's first try to find the value of alpha. So we can pretty much focus on this equation right here. let's take this equation. Actually there are two equations hidden in here, right? There are two equations here. So this is one of the equations, and from that equation we can say, okay, the value of alpha will be equal to c sub 1 a sub 2 minus c sub 2 a sub 1 divided by a sub 1 b sub 2 minus a sub 2 b sub 1. And then let's also try to find out what would be the value of alpha squared here. So now I'm going to take this part of the equation. So I'm going to take this part which is equal to this part right here. So from there I'm going to try and find the value of alpha squared, right? So from here we can say, okay, the alpha squared will be whatever we have in the denominator, that is a sub 1 b sub 2 minus a sub 2 b sub 1, and then whatever we have in the denominator of alpha squared, that will go to the numerator, that will be b sub 1 c sub 2 minus b sub 2 c sub 1. So from here we get alpha and alpha squared. Now if we square this one, from here we can say, okay, if alpha is this, then alpha squared will be a whole square of that thing, that will be the alpha squared, and that will be nothing but the same thing here, a sub 1 b sub 2 minus a sub 2 b sub 1, and then in the numerator we have c sub 1 a sub 2 minus c sub 2 a sub 1, and whole square of that, right? So that is one alpha square value, and here we have another alpha square value. Now let's focus on these two, right? So this value, the value in the white box right here, that represents alpha square, and here also this other value in the white box, it also represents alpha squared. Now they must be equal because they both represent alpha squared, so they must be equal. So now I'm going to equate them, right? So let's equate them and then see what happens. So now what I'm going to do, I'm going to equate them. Now I'm going to write the second one first, which is, let's say, suppose we have b sub 1 c sub 2 minus b sub 2 c sub 1 whole divided by a sub 1 b sub 2 minus a sub 2 b sub 1. So this is one value of alpha squared, and that must be equal to the other value of alpha squared, which is actually the whole square of, it is the whole square of c sub 1 a sub 2 minus c sub 2 a sub 1 whole divided by a sub 1 b sub 2 minus a sub 2 b sub 1, and whole square of that, right? So that's what we get from this equality here, or by comparing the two values of alpha squared, right? Now from here we can say, okay, now let's do something on the right hand side. Say for example on the left hand side I'm going to keep it as is, and so let's say b sub 1 c sub 2 minus b sub 2 c sub 1 divided by a sub 1 b sub 2 minus a sub 2 b sub 1 is equal to, now I'm going to square them separately, right? In the numerator I'm going to say, okay, this must be c sub 1 a sub 2 minus c sub 2 a sub 1 whole squared right there, and then in the denominator also we are going to do a whole square here, so that would be a sub 1 b sub 2 minus a sub 2 b sub 1. Now from here what do we get? Well, from here we can say, okay, now you see that we have the same denominator here and here. Here also we have two of them. Here we have two of them. We have a whole square. So we have two of them here on the right hand side in the denominator, and on the left hand side we have one of them. So one of them will cancel each other, or maybe we can do it like this. We can say, okay, now let's bring this portion to the left hand side. Let's cross multiply this onto the left hand side. So then our left hand side is going to look like this. It will be whatever we originally have, which is b sub 1 c sub 2 minus b sub 2 c sub 1 whole divided by, we have a sub 1 b sub 2 minus a sub 2 b sub 1, and we are going to bring the denominator from the right hand side onto the left hand side. So it will come here as a multiplication here, so it will be multiplied on the left hand side. So then we are going to have a sub 1 b sub 2 minus a sub 2 b sub 1 whole square. That's exactly what I am bringing from the right hand side to the left hand side, and then we are now going to be left with only the numerator on the right hand side, which is c sub 1 a sub 2 minus c sub 2 a sub 1 whole squared, right? Now here if you see, we have this portion right here. Now I am enclosing them with a red parenthesis. So in the denominator we have one of them, and in the numerator we have two of them. So the 1 going to cancel each other. That means the denominator will become 1, and in the numerator side we will have only one of them, one of the a sub 1 b sub 2 minus a sub 2 b sub 1. We will have one of those factors. So then from here we can say, okay, this is clearly b sub 1 c sub 2 minus b sub 2 c sub 1 multiplied by, we have a sub 1 b sub 2 minus a sub 2 b sub 1 is equal to, we have c sub 1 a sub 2 minus c sub 2 a sub 1 whole square. Now if we just rearrange a little bit, if we write the second factor as the first one here, so let me do it like this. Now I'm going to just write this second one as the first factor here, which is okay. I'm just kind of interchanging them, right? So I'm going to say, okay, now can we say that a sub 1 b sub 2 minus a sub 2 b sub 1 multiplied by, now I'm going to write this one, the first factor, which is actually b sub 1 c sub 2 minus b sub 2 c sub 1 is equal to, right hand side I'm going to keep it as is, that will be c sub 1 a sub 2 minus c sub 2 a sub 1 whole square, and that is the necessary condition when two quadratic equations have a common root, and that is the necessary condition. So let me highlight that. Now we can also express this in terms of determinant. If you are familiar with determinant, they're going to look like this. So we can have two determinants written like this. Now a sub 1 b sub 2 minus a sub 2 b sub 1, it would definitely look like a determinant which is like this. So now I'm going to write it in form of determinants. So suppose we can say, okay, a sub 1 b sub 1 a sub 2 b sub 2, this is that determinant. It will give us the value. If you know how to evaluate a determinant, actually it will be a cross multiplication like this. First we will get the a sub 1 b sub 2 minus a sub 2 b sub 1. That is how the determinant is evaluated. So that's the first determinant, and then we can say, okay, this multiplied by the second determinant will be like this. The second one will be b sub 1 c sub 1 and then b sub 2 c sub 2. That will be the second determinant, and there again we get the value b sub 1 c sub 2 minus b sub 2 c sub 1, and all of that will be equal to the third determinant, which will be c sub 1 a sub 1 then c sub 2 a sub 2 and whole square of that, right? So in the determinant form also we can express the necessary condition, which is going to look like this. I hope everything made sense. Thank you for watching. See you in the next video.